What I want to look at in this video is 3x3 systems of equations and matrices. How can we combine these such that we can use matrices and augmented matrices of 3x3 systems in order to allow us to solve them much quicker and more efficiently than having to do a lot of algebra and a lot of work and manipulation. Let's set the scene with an example. So let's imagine I've got a parabola and it has a curve y equals ax squared plus bx plus c. Now on that parabola I'm going to give you 3 points which are a, b and c shown on the diagram. The question I want to answer is how can we find the constants a, b and c. Now each of those points gives you an x value and the associated y value for that x. Now because I've got 3 of them, what that allows me to do is set up 3 distinct equations with these points, and I'll have 3 unknown variables there, so a, b and c, and I can then somehow use these together to find the a, b and c. Now remember, we are looking for 3 unknowns. If we've got 3 unknowns, we need 3 equations. So let's imagine I take each of the points. So let's start with the point at 1, 2. If I substitute that into the parabola, so the y equals ax squared plus bx plus c, what I'll end up getting is a plus b plus c equals 2. If I then take the second point, which is located at 2, 4, and I then substitute that one in, what I'll end up getting is 4a plus 2b plus c equals 4. And then the last point, which was at negative 1, 4, if again I take that and I substitute it in the exact same way as I did before, I get a minus b plus c equals 4. Now what you'll notice here then is I've got 3 equations, so I've got a system of equations of 3 variables with 3 equations associated with them, so I can solve this to find the a, b and the c. And in order to do that, what I'm going to do is write it in the form of ax plus b. So for that case I'll have 1, 1, 1, 4, 2, 1, 1, negative 1, 1. So then going to be times the x1, which is a matrix, i.e. the vector, with our variables in it, so the a, the b and the c. And that's going to equal the solutions here, which is 2, 4, 4. So now that I've got that, I can create my augmented matrix, which is combining these 2 matrices together in a more compact form. So that will then give me 1, 1, 1, 2, then got 4, 2, 1, 4, and I'll have 1, negative 1, 1, and 4 there. So I've now got as the augmented matrix representing this system of equations. Now I want to use this to solve it, and in order to do that, what I'm going to do is turn it into what's called upper triangular form. Now if I turn it into upper triangular form, this little triangle of numbers here, so the x value in the second row and the x and y value in the third row are going to be 0. If I can do that, what that means is I'll be able to read off a value for y, put it into the next one to get my, read off a value for z, put it into the next one to get my y, and then put the z and the y in the top one to get my x. So I've got to figure out, using my elementary row operations, how to do this. Well, for the second one, if I do row 2 take away 4 of row 1, that's going to eliminate this first variable here, because I'm going to do 4 take away 4, which will get rid of that. If I then look at the third row, and I do row 3 take away row 1 on its own, what that's going to do is do 1 take away 1, so that's going to eliminate that there. So when I do it, the first row does not change. So I've done nothing to that first row, I've used it, but remember that one doesn't change. Second one is row 2 take away 4 of row 1. So I've got 4 take away 4, that's going to give me 0. I've then got 2 take away 4 of these, so 2 take away 4 gives me negative 2. I've then got 1 take away 4 of these, so 1 take away 4 gives me negative 3, and I've then got 4 take away 2 times 4, which gives me negative 4. My bottom row, I then do row 3 take away row 1. So I've got 1 take away 1, which is 0. I've then got negative 1, take away 1, which gives me negative 2. I've then got 1, take away 1, which then gives me 0. And I've then got 4, take away 2, which gives me 2. So what I can then do is if I swap these two rows around, so if I do row 2 swapped with row 3, what I'll then get is a matrix that reads 1, 1, 1, 2, 0, negative 2, 0, 2, and then 0, negative 2, negative 3, negative 4. And what I can then do is, in order to eliminate this variable here, what I can then do is just take this one and subtract the second row from it. So if I do then row 3, take away row 2, that will eliminate this here. So that will then give me 1, 1, 1, 2. Second row will stay the exact same. I've not done anything to it. I've used it, but I've not done anything. So 0, negative 2, 0, 2. And then my third row becomes this, take away row 2. So I've got 0, take away 0, which is 0. Negative 2, take away negative 2. So negative 2 plus 2, which is 0. I've then got negative 3, take away 0. So it's just negative 3. And I've then got negative 4, take away 2, which gives me negative 6. So what I've now got is 3 equations for the a, b, and c that I can solve. My bottom equation here gives me negative 3z is equal to negative 6. So z is equal to 2. The middle one there gives me negative 2y equals 2. So I get y is equal to negative 1. And the top one there tells me x plus y plus z equals 2. So if I substitute in my y and my z there, I've got x minus 1 plus 1 equals 2. So I'll then get x plus 1 equals 2. So then I know that x is equal to 1. Now remember, I've used the variables x, y, and z here out of habit. These should actually be a, b, and c. So just an illustration there of how you've got to remember to keep the associated variables. So I can then substitute it back into my original equation for my parabola, which was ax squared plus bx plus c. And I can tell you that it's x squared plus bx, so minus x plus c plus 2. So there you go, I've solved it for those values of a, b, and c to get my original parabola. Elementary row operations can be applied to a 3x3 matrix in the exact same way as a 2x2. We could do a 4x4 matrix the exact same way as we did before. Get it in the augmented form first and we're laughing. We're ready to go. And this is a key part here. If you can get this upper triangular form, you can read off solutions. So get it into that format so that it's much easier to do and quicker and efficient. Let's look at another example. Let's imagine I want you to solve the system of equations given by these 3 equations here. First thing we want to do when we get a question like this is put it in our augmented matrix. Now, I'm going to give you a hint. You can actually just write this down just by looking at the coefficients and the solutions. So I could write it down and say my augmented matrix is 2, negative 1, 1, 5. I've then got 1, minus 3, 2, 2. And I've then got 2, 1, 4, negative 3. So there you go, there's my augmented matrix straight away. Now what I'm actually going to do to begin with is I'm going to do row 1 and swap it with row 2. And you'll see why in just a second. Because what that will give me is 1, negative 3, 2, and 2. It'll then give me 2, negative 1, 1, and 5. And then 2, 1, 4, and negative 3. Now the reason I've done it is because now what I can do is do row 2, take away 2 of row 1, and row 3, take away 2 of row 1 as well. If I'd done it before, what I'd have had to do is row 2 take away a half of row 1. So that would start to bring fractions into place. We want to keep it nice and straightforward. So if you can swap rows to keep numbers whole without bringing in fractions and decimals, I would suggest doing that. If we didn't, and we used the fractions throughout, we wouldn't be wrong. We just have to do a little bit more thinking. So if I were to do this, what I've done there, I'd end up getting same top row, 1, negative 3, 2 and 2. This would then become this row, take away 2 of that, so I'd then get 0. I get negative 1 minus minus 6, so that would be 5. I'd then get 1 to take away 4, so I'd get negative 3, then 5. Take away 2 of those, so 5 take away 4, which gives me 1. The bottom row then becomes 0. I've then got 1 minus minus 6, so I've then got 7. I've then got 4 minus 4, which gives me 0. And I've then got negative 3 minus 4, that gives me minus 7. Now I'm actually going to cheat a little bit here. What I'm going to do is take my solution from here. Because if you look at this last row here, remembering our columns are associated with each variable, x, y and z, what actually this last row lets me write down is that 7y is equal to negative 7. So y is equal to negative 1. I can cheat sometimes if I end up getting that. If you get a row with 2 zeros in it, there you go, there's part of your solution. If it specifically wants upper triangular form, you have to write it. So if it specifically wanted that, what I'd do is I'd swap these 2 rows round and then do a subtraction from there. Or I could even do it here, I just have slightly different numbers to work with. But because I've noticed that, I can just jump ahead, do 7y equals negative 7, y equals negative 1. This second row here tells me that 5y minus 3z is equal to 1. So 5y is negative 5. If I substitute that in, I get negative 5 minus 3z equals 1. Shift the negative 5 over, and I get negative 3z is equal to 6. So z is equal to negative 2. And then the top row there, so let's just do that down here so I've got some space. Row 1 tells me I've got x minus 3y plus 2z equals 2. Shift the y and the z across, and I get that x is equal to 2. It's the minus 3y here, so it becomes a plus 3y. So it then becomes a plus 3 times negative 1. This becomes a minus 2z, so it's then minus 2 times the z, which is negative 2. So I've then got 2 minus 3 plus 4. So 2 plus 4 is 6 minus 3. I know that x is then equal to 3. So the solution that fits all 3 of these equations in my system of equations occurs when x is 3, y is negative 1, and z is negative 2. So putting it in this augmented matrix form allowed me to solve it. Now, as I've said, sometimes you get lucky and we end up with a nice row like this with 2 zeros in it, which is great. Use it, manipulate it, and take it from there if you can. If not, we put it in the upper triangular form, so I'd look to get all of these values here equal to 0. And if I can do that, I can then just read off the 3 variables line by line and get my solutions. It's easy once we get in the habit of how we manipulate these matrices and how we remember each of the row operations we can do and how we can combine them. Remember those and you'll manage this no problem at all.